this comes up over and over again. It also has been true that over the last couple years in our role in managing this relationship that we've confirmed that we have a need and a demand for dedicated resources from the Fraunhofer network here in South Carolina. And that has resulted in Dr. Marcel Schaefer relocating to South Carolina earlier this year. We're excited to have him here. We're now a double duo here on the ground in South Carolina, helping companies to find expertise within the network and assisting them along the way, supporting them in developing applications for matching funding that's available from the South Carolina Department of Commerce. We have a set of scoring criteria and so forth. We would love for any of you that are on today's meeting, if you're interested in this topic or others, please contact Marcel or I. We'd be happy to get with you and understand your needs and try to make those connections for you and see if a funding opportunity is available for you or well. With that, let me turn it over to Dr. Marcel Schaefer, who will introduce our speaker and the topic today.
Yeah, thank you, Suzanne. I'm happy to be here once again. For all those who just entered, if you're not muted, please be on mute, stay on mute until we open the question and answer session. I'm only here introducing Frank Schnieke from the Fraunhofer IESE or IESE, or whatever you would pronounce it, standing for Experimental Software Engineering, so the institute in Germany in Kaiserslautern. I've been there, very nice building, as you can see in Frank's background. Frank is, well, as the title says, Industry 4.0 system architecture, so he's an expert in that. However, I'd like to call him Industry 4.0 multiplier, because that's basically what he is. He's been working with me and my team to bring us up to speed on Industry 4.0 in the past, for example, in one of the other Alliance projects, where we create 2 one-day courses, motivating, teaching Industry 4.0 and modern manufacturing technologies and best practices. So if you want to know more about that, contact me or Suzanne, shoot us an email or call us. The first course will be offered in end of September. Frank is, as I said, Industry 4.0 expert, multiplier, system architecture expert at the Fraunhofer IESE. In this role, Frank advises manufacturing companies, supports them in the successful implementation, supports them in this implementation Industry 4.0. So from the very start, from the the question, hey, there's this new thing, we gotta do something about it, but we have no idea what. Back to really implementing and seeing the enhancement of it and the benefits. His focus is, or the research focus is on software and system architectures to enable improvement in production. He also coordinates the implementation of the Eclipse Basyx middleware. We'll hear more about that later on, which supports central Industry 4.0 concepts, enables, accelerates the path of the people into the world of Industry 4.0. Standardization is a big topic here. Disclaimer, spoiler. Before we do that, before we get into the video screening of Frank, let us show a video that shows the concepts in a nutshell and get ourselves into the right setup. And please keep in mind, put all questions you might have into the chat. We get to that after the 2 video presentations. And I guess we can start the first of the 2 videos.
The world before Industry 4.0 will soon be a thing of the past. Don't get left behind. Up to now, you've been wasting time checking your production facilities individually. Your machines speak different languages, and failures often happen unexpectedly. All this belongs to the past with the open source middleware Eclipse Basyx. With Basyx, your machines and your IT have a uniform interface, the Asset Administration Shell, and thus speak the same language. Information is displayed at one glance, and failures are detected early. Has the documentation of your production been complex and confusing? Then Basyx will help you document your manufacturing processes with digital twins. Also, you yourself decide which information is passed on to your customers. Even if the manufacturing of your core products has so far been reliable and economical, the markets increasingly demand flexibility. However, modification of your production plant has been complex and expensive. With Basyx, every product can be manufactured individually. New machines can be integrated into your production plant in no time. This means that you can realize products and product variants in the smallest lot sizes. This makes your production adaptable and opens up new business models. Has the digitalization of your facilities been rather intimidating and frightening? There's no reason to panic. Basyx integrates all the assets of your production into digital manufacturing. Dare to take the step towards Industry 4.0 and lead your company into the digital future with Basyx.
That was the first introduction into the topic that's going to come now. And just right away, start the next video, I would say.
Successfully implementing Industry 4.0 is hard. Or is it? What are typical Industry 4.0 use cases? And how can we make Industry 4.0 happen? In the following minutes, we will take a look at core benefits of Industry 4.0 and how they can be implemented by using a sound foundation of well-defined concepts. Additionally, I will showcase how open source tooling can get you a head start in the world of Industry 4.0. However, before we take the deep dive, let's talk about my background. My name is Frank Schnicke, and I am expert for Industry 4.0 system architectures at Fraunhofer IESE. Here, I'm advising companies on how to successfully implement Industry 4.0. Additionally, I'm researching changeable system architectures and digital twins that enable an efficient lot size. Furthermore, I'm coordinating the implementation of Eclipse Basyx and supervise its usage for implementing core Industry 4.0 use cases. What are these use cases? Let's take a look. Imagine the following situation. You are sitting in your comfortable chair in your office, and you would like to get an overview over what your plant is doing in this very second. With a single click, you can access all available information in one common dashboard. There, you can see all relevant key performance indicators, like the overall equipment effectiveness. Additionally, you're getting live data of the different devices of the shop floor and can check with your bare eyes if everything's working as expected. However, today you need to consult a lot of data sources or even take a walk through your shop floor to get this overview. Additionally, data is distributed in different systems, or even worse, redundantly available, and you need to figure out if all data is consistent and up to date. Industry 4.0 enables you to create bridges between data silos and thus create a holistic overview by connecting data from the enterprise level with data from the shop floor. Another very interesting use case is an efficient lot size one. Imagine having the possibility to tailor a product you're buying, even in the smallest details, without having to pay a premium. Today's customers ask more and more for individualized products. Additionally, Black Swan events like the current COVID pandemic showcase that quick reaction to, for example, changing supply chains is key for market success. Today, changing the product being produced by a factory is a cumbersome task. Devices have to be reprogrammed, interactions have to be tested, and lots of effort has to be spent. Imagine that instead of having to reprogram your devices and to stop production, you can easily specify a new product by providing a manufacturing recipe describing different production steps and their parameters. Thus, products can be easily defined using high-level descriptions. Similarly, imagine introducing a new device to a factory without lengthy integration or tests. Instead, a device is integrated by leveraging its digital twin for virtual testing. In consequence, device integration is made easy. To fully leverage the potential of the system, process steps can be dynamically mapped to service interfaces provided by devices. Thus, with each new order, a new optimal mapping can be created, allowing easy rescheduling or reaction to unexpected events like device failures. This is just a small overview over the plethora of use cases enabled by Industry 4.0. However, how can these use cases be realized? How can different data sources be integrated into a holistic system consisting of digital twins? For making this happen, a strong tool support is needed. Precisely this tool support is provided by Eclipse Basyx. What is Eclipse Basyx? Well, it is an open source software developed by Fraunhofer Jese and other partners, enabling efficient handling of digital twins and much more. It is provided as an open source tool together with the Eclipse Foundation and thus available free of charge. Due to its license, it is usable in commercial applications and products without having to pay any license fees. For supporting the previously described use cases, Eclipse Basyx defines 4 core building blocks. Each building block is usable on its own. Thus, with Eclipse Basyx, you can select the building blocks most appropriate to a use case. In consequence, there's no need for Big Bang adoption of the different concepts provided by Basyx. Let's start with the virtual automation bus. Industry 4.0 is often called the Industrial Internet of Things. This name contains one important aspect of Industry 4.0, the Internet of Things. Thus, for leveraging the full potential of Industry 4.0, a homogeneous communication system is key. Data needs to be available to different entities without any obstacles, like different communication protocols. However, if we take a look at today's shop floor, we will see a multitude of different communication protocols. There exists a wide selection of protocols ranging from Modbus to Profinet to OPC UA. For realizing Industry 4.0, these protocols need to be integrated into a common namespace. Thus, we invented the concept of the virtual automation bus. The virtual automation bus integrates arbitrary protocols and communication networks by defining common interaction primitives as intermediate language. These primitives focus on data handling, so create, read, update, and delete, as well as on method invocation. In consequence, a mapping between protocols and this intermediate language can be created, enabling efficient mapping of different protocols like Modbus, OPC UA, or even HTTP REST onto each other. Gateway components realize this protocol translations transparent to the applications. Additionally, the directory keeps track of the virtual path to different entities. Thus, applications can use the directory as a single point of entry to the virtual automation bus system. Additionally, devices can easily be redeployed in the network by simply updating the access path in the directory. By applying the virtual automation bus, we can connect the factory into a common namespace. Thus, we can communicate with each single device. Next, we need to take a look at the description of the devices. To allow uniform access to resources, a common interface needs to be defined. This is done by the control component. The control component provides an abstract access to manufacturing resources. Thus, the service interface of a device exposes a multitude of different variables controlled by state machines. These state machines provide insights into the operation of the device itself. For example, the occupation state, the execution mode, and the execution state can easily be accessed. Thus, applications can gather data, for instance, for an overall equipment effectiveness, by simply observing the execution state without having to need to know about the specifics of the device. Last but not least, assets need to be described in all relevant attributes to allow easy integration with each other and in higher level applications. This is done by utilizing the digital twin of devices, or more precisely, their asset administration shells. Of course, you're wondering now, what is an asset administration shell? Let's take a look. The asset administration shell is a digital representation of assets. It is being specified by a German Corporation of Industry and Research in coordination with other European countries. Thus, it is not a manufacturing specific concept, but instead an independent concept. For the asset administration shell, or AAS for short, the data format, its serialization in different technologies like JSON, as well as its runtime interfaces are being specified and standardized. Thus, in near future, each relevant entity of Industry 4.0 will be described by its AAS. Each product and each device will provide its AAS and thus easily integrate into the manufacturing of the future. Imagine buying a new device. Before this device is even delivered to you, you will receive its digital twin in form of the asset administration shell. Since its data format and interfaces are well defined and standardized, it integrates out of the box with AAS-compatible factory control software. Thus, virtual commissioning as well as manufacturing planning can be performed automatically. The need for tailoring of information and thus the need for human involvement will be reduced to an absolute minimum. Now, how does an AAS consists of various submodels, each submodel describing a key aspect of an asset. For example, there's a submodel identifying the asset, called the digital nameplate. There's a submodel for describing physical properties, like size and weight of an asset. Additionally, by providing a simulation submodel, the asset can be easily integrated into simulation frameworks, thus enabling the generation of, for example, evidences of. By bringing all these concepts together, we can implement a changeable plant system and thus enable an efficient lot size one, as well as other exciting use cases. Both products and devices are described using the AAS. By accessing its well-defined interfaces, orchestration applications can generate manufacturing schedules on the fly. In consequence, introducing a new product type to your plant is as easy as deploying a new asset administration shell in your system. Additionally, new devices can be integrated in the same manner. We created at Fraunhofer IESE some time ago a demonstrator for the Hanover Fair here in Germany. Initially, we planned to use a big transport robot to move small pieces between different kind of service providers. We developed the system, we developed the asset administration shells, and we described the different service providers using asset administration shells. However, suddenly we were messaged that this transport robot would not be possible. So what did we do then? Well, we replaced the service provider transport, in this case the transport robot, with another service provider. We involved the visitor of our demonstrator by letting him perform the transport step. The benefit here was clear. We could exchange service providers, so for example here transport, without having to wonder what will be the results of this change in our plant. Since we only exchanged the service provider on its own, nothing in the programming of our plant itself had to change. Now we have learned about the building blocks of Eclipse Basyx. However, how are they provided? Eclipse Basyx provides easy-to-use off-the-shelf components, enabling easy deployment of the AES infrastructure. These components are, for example, provided as Docker images that can be easily configured without any programming knowledge. For example, setting up your infrastructure as well as a comprehensive dashboard is as easy. Additionally, Eclipse Basyx provides rich software development kits, enabling tailoring basics to the very need of your use cases. By providing software development kits for Java, C++, and C#, we are covering a broad scope of programming languages and use cases. Thus, we enable developers to pick the SDKs they feel most comfortable with. Furthermore, there's even more tooling available for the AES and Industry 4.0. The ASX Package Explorer enables you to quickly design your digital twins as asset administration shells. Through a comprehensive user interface, even non-programmers can easily instantiate digital twins for their respective plans and use cases. Since the ASX Package Explorer is also implemented using the well-defined data model of the AES, it integrates out of the box with Eclipse Basyx. In consequence, AES can be easily designed by using the ASX Package Explorer and brought into life with Eclipse Basyx. To put it in a nutshell, standards like the Asset Administration Shell build the very foundation of a successful implementation of Industry 4.0. Eclipse Basyx enables you to have a quick start with Industry 4.0 by providing powerful off-the-shelf components. Additionally, it is easy to tailor and easy to extend due to its open source nature. We as Fraunhofer IESE have lots of experience in successfully implementing Industry 4.0 in companies of various sizes. Thus, we can support you in every step of Industry 4.0, starting with the defining the use cases to implementing them with state-of-the-art technology.
All right. Thank you, Frank, for providing the video. Now it's time to talk. Now we have time for question and answers. Before that, because I'm pretty sure nobody here has heard the term asset administration cell so far. I just wanted to add that this concept is not only a concept pushed by Fraunhofer IESE, but it's pushed by many companies in the consortium called Platform Industry 4.0. I know that because Frank told me so. In this consortium are, for example, BMW, Audi, Daimler, Volkswagen, Amazon, AWS, IBM, Microsoft, HP, Airbus, General Electric, SAP, Siemens, Bosch, T-Mobile, and others. So this is not only a very small thing, but something that is pushed by the big players, and therefore a very important concept. And I guess now we have room for questions. I have only one question so far from Rusty Coleman. Hi, Rusty. Good morning. Does the application, the asset administration shell, follow the RAMI 4.0 framework? Frank.
So thanks for this question. To answer it short, yes, it does. For the other participants who are maybe not aware what the RAMI 4.0 is, it's the reference architecture model for Industry 4.0. It is coming from the same consortium that Marcel just described here in Germany, called the Platform Industry 4.0. And there, with, for example, this RAMI 4.0, let's say the overall framework of Industry 4.0 here in Germany and in Europe is being described. And one of these components that is being described there is exactly this asset administration shell.
Does that answer the question, Rusty? I guess it does. So if people have more questions, feel free to answer. This is the topic that is coming up very highly here in South Carolina. So please use the opportunity to speak to an absolute expert in this field. There's a question from Pete. Good morning, Pete. Has Frank seen large companies supporting Basyx as suppliers to use it and link this to the supply chain? That's a good question, Frank.
Mm-hmm. So what we are seeing right now is that surrounding Basyx, there's a rich, let's say, world or environment, or even call it ecosystem of projects coming into existence. So that means, on the one hand, we are doing research projects sponsored by the German government that are focusing on several aspects of the asset administration shell and Basyx. And one of these is exactly working on this linking of supply chains. So that means we are taking a look there at the different aspects of what does it actually mean to pass the digital twin along the supply chain. And additionally, we are also in discussions and in projects with the industry. And as initially also told by Marcel, I'm advising the industry there. And yes, this is a point that I'm seeing more and more. So I know that there are some companies that are right now even requiring, or at least planning to require at some point on time, to from their suppliers to provide this asset administration shell, because it solves all these issues that you have with supply chains, that you're getting data provided, and then you have to figure out what is the data format, what are the semantics of this, and each supplier is maybe supplying the data a little bit differently. And then the vision is that if every supplier is providing you this asset administration shell, all these, let's say, these tailoring questions that right now are creating lots and lots of effort are completely out of the picture, because you precisely know what data format will you getting. It will be the asset administration shell, and you will know where to look for which information. For example, the digital nameplate I mentioned in the video will tell you exactly what the asset is being about. We are right now seeing also standardization efforts of, for example, creating submodels for digital calibration certificates. So that means that independent of how the device was calibrated, you will be getting this information in the same data format using the same data models and even the same runtime behavior. So you can very easily integrate the data from your suppliers or in your asset administration shell system that you have.
We have another question. Thanks, Frank. What governing board or organization is defining the interfaces, and how mature is the standard? Is the first part of the question. Do you want to go ahead?
Yeah, gladly. So the overall organization that is driving this is called the Platform Industry 4.0, which is let's say mainly a Germany-based entity, but it's also being supported by other companies in Europe, and there are also, let's say, instantiations of this in other countries in Europe. And as Marcel mentioned, there are very big players involved in this. So coming from industry, BMW, SAP, and so on and so forth, and also from research, for example, we as Fraunhofer and other institutes. Additionally, the German government is very much involved in this. So let's say the overall vision of the Platform Industry 4.0 is to really create these standards and concepts that will be driving Industry 4.0 in the next 10 years here in Germany and also in Europe. And thus, let's say the governing board organization there is the Platform Industry 4.0.
So where can machine builders, for example, in the US, go to get this interface protocol? Is it internationally available? Okay.
So I just realized I skipped over a part how major is the standard. So coming back to this, this is of course is not a standard that is available since 10 years, but nevertheless it's being iterated on all the time, and there's already lots and lots of documentation available that describes how to use this and what are the concepts behind this. And let's say right now we're having the version 2.0.1 being released of the meta model and the data serialization. We are right now expecting the release of the version 1.0 of the HTTP REST interface of the asset administration shell to happen somewhere around November. So it's a standard that is still growing, but nevertheless, as already mentioned, there's a lot of, let's say, drive behind this, and thus it's maturing more and more every second. Coming to the second part, where can machine builders get this interface protocol? So what I really like about this whole endeavor that the Platform Industry 4.0 is doing here is that what they are doing is not happening behind closed doors, and you, for example, have to pay to get access to all the specifications, but they are available free of charge. That means if you would like to take a look at what is already there, you can just right now or after this webinar go to Google, type in details of the asset administration shell, and you will find these documents available. You don't even have to put your email address or anything. You can just download the PDFs and take a look at them. There's lots and lots of information available, and it's maybe not the easiest lecture you should read before going to bed, but everything's being defined there. That means we are not talking only on the conceptual level, but really we are talking about having a standardization on how does a JSON of an asset administration shell look like? How does an XML of an asset administration shell look like? And this really helps to, let's say, guarantee this interoperability, because if you receive an asset administration shell based on the standard, you know exactly how the JSON will look like.
And I want to add, there are videos on YouTube that give you a step-by-step introduction into this. Like I'm not sure how the exact title is, but one of it is like asset administration shell set up in 15 minutes. So it's doable. Of course, you need a computer for this, but it's not too bad.
Okay, there's another good question in the chat about how you ensure security with the connection points of edge devices, and how do you cyber harden the application?
So in general, what the asset administration shell is suggesting is that on the conceptual level, the attribute-based access control will be used. That means that you can define several attributes and link with these attributes then certain access rights. Like, for example, plant owner, of course, can read everything. If I'm a worker that is maintaining the, let's say, the different devices, then I am only allowed to access the devices that I should be maintaining at the very second. And for example, I'm not able to change a product recipe or something like this. So this is on the one hand what the asset administration shell is providing there. Of course, when we take a look at this with the connection point with edge devices, then this is, let's say, a topic that is on the conceptual level, I would say, below the asset administration shell, in the sense of that the asset administration shell only address these high-level points like attribute-based access control. If you would like to have something more low-level, then there's not something that Eclipse Basyx is delivering out of the box, but we are able to integrate with the solutions that you already have in place or that you would like to adopt in future. And I guess that's also really the beauty of this open source approach that we're having here, that in the end, if we are not providing something that you need, you can very easily tailor your code and adapt it. And for this, we have, I would say, really great documentation that really showcases how to integrate different protocols, how to integrate devices, how to integrate data sources, like, for example, product lifecycle management systems or enterprise resource management systems.
Okay.
I want to add that if you're a plant owner, you probably don't have too much information or knowledge background in cybersecurity, so I wouldn't recommend you having access to all the channels all the time.
Exactly.
Just to be sure that we're answering the question on how do we cyber itself, are we saying that it can be cyber hardened as, you know, in a customizable way by the user? So whatever cyber approach they're using for other applications in their organization can be applied to this as well, or?
Yes, exactly. So, for example, if we talk about having some kind of single sign-on or Active Directory, something like this, which is already available in the company, we are planning, and this is something that we are still developing right now, we are planning to integrate with these, for example, using these token-based security mechanisms like open authentication, OAuth, and so on and so forth, so that really we can integrate with the infrastructure that is already there.
Mm-hmm. Okay, thanks. Okay, do we have other questions? Feel free to put them in the chat.
Otherwise, I'm going to ask a question. I talked to Frank about this earlier, but Frank, of course, knows the German ecosystem and manufacturing. In South Carolina, this might be a little different. Of course, here we have the very sophisticated Industry 4.0 ready big manufacturers, but we also have those who are struggling with automation, like they're in the beginning of the journey, very beginning of the journey, and Industry 4.0 is a long step ahead. Frank, what would you recommend to those manufacturers? Like, here's someone in the audience saying, hey, I have a plan, I want to go Industry 4.0, but I'm very far away. What would you suggest him to do?
Yeah, that's actually a good question, and that's a point that we also commonly see here in Germany, because it's the same here. We have some companies who are really far ahead with the implementation, and other companies that are more or less doing a lot of manual work, so far removed from Industry 4.0. And what I also give as advice there is that at the very first part, companies really have to figure out why do they want to do Industry 4.0. Because it's really important that you are not implementing Industry 4.0 and the digital twin just because it sounds nice, but instead that you have a concrete use case that is guiding the implementation that you're doing. And as I said in the videos, for example, what we are doing is that we are doing workshops that help identifying these use cases and also help breaking these use cases down into small intermediate steps. Because let's say the point is that companies very often, they have a vision where they want to go, but implementing this vision as a big bang is just will take too long. And by breaking it down in these small steps, we can really ensure that after each iteration, there will be a usable system, and a usable system that is already providing some kind of value. Because if we wait until, let's say, we want to implement Industry 4.0 in its fullest extent within a big bang approach, then you will be developing 5 years, and then you will realize that requirements have changed that much that maybe what we are developing is not the right point anymore. So I think defining a goal and then breaking this down is, from my perspective, let's say the very first step, and then based on this as kind of roadmap or guideline, then we can start realizing Industry 4.0.
Yeah, quick win, right? 5 years. Imagine what was the world like 5 years ago.
Yeah.
So we have another question in the chat. Peter asked, so at this stage, Basyx is sufficiently mature for deployment in the field for US firms, question mark.
Mm-hmm. So yes, it is. So in Germany, we are already deploying this with big industry customers. We are deploying it, and that's also a very interesting point, with industry customers of varying sizes. So like really small enterprises having like 50 members, or even really large enterprises that are globally working and having several 10,000 of customers. So yes, you can grab these aspects there and really use it to implement Industry 4.0.
So the second half, thank you, second half of the question. And if so, how would they contract with IEC to deploy and configure Basyx?
Mm-hmm. So in general, the easiest way is that, let's say we have a discussion on what you would like to do, and then we can very easily provide an offer where we will specify what will be done, put a price tag on this, and then start to collaborate based on this offer.
And I want to add that now that Fraunhofer is also local in South Carolina, we can also route this through local entities. So it wouldn't be too much of a hassle with international contracts.
I was going to iterate that point as well, that if companies are interested in exploring this, Marcel and I can facilitate a conversation with the colleagues in Germany, and then we can use local teams here to help with the implementation. So please let us know if you're interested in that. Okay. Do we have any more questions? Feel free to put them in the chat. Well, you can see, Frank, I think that, you know, as we mentioned at the beginning, that this is a popular topic here. Can you give us a range? We do have another question about how long does the implementation take? I assume it's a range, but can you give us an idea?
Just to make sure, you mean the implementation of taking Eclipse Basyx and implementing Industry 4.0 with it? Okay. So in general, that's let's say it's the most liked answer of a software engineer. It depends. So of course, it strongly depends on what we would like to implement. If we are talking about providing a dashboard in the sense of, as I showed in the video, that you have a nice overview over your plant, what is it doing? then we are talking about, let's say, a time span of, yeah, let's say we can talk within, let's say, 2 to 3 months, depending on what actually should be done and how much support on premise is necessary. If we are talking about implementing a complete, let's say, service-based production, enabling an efficient lot size 1 and arbitrarily exchanging all products, then that's of course a completely different topic. And interestingly enough, let's say there are multiple degrees of freedom that specify the duration of this implementation. And one that's obvious is what we would like to implement, but also what was previously addressed, what is our starting point? So where are we starting our journey to Industry 4.0, and what, let's say, how much intermediate steps need to be taken to reach this goal of implementing the vision of yours?
I want to add how much IT staff the company has to also support, right?
Exactly, yeah. So if in the end, let's say, we have to go to the company and start connecting wires, then it takes longer than if you just have a counterpart that we can tell, here connect these devices with these machines, here connect these sensors, plug these Ethernet cables in, and then we're ready to go. And I guess that's also a very interesting point why implementing Industry 4.0 is not something that is just done with the snap of our fingers, because it strongly depends on a lot of factors, and there's not, let's say, there is no box that you can buy and put in your shop floor and that's Industry 4.0. But we really have to take a look at what is actually happening in your companies, and then we can start to derive a roadmap or implementation plan based on this.
That's why the workshops are so helpful, right? To figure out what is the lowest hanging fruit, only go for this one and see the benefits, see what we can do here, and then step by step move forward.
Okay. Do we have any more questions? And some nice comments from folks that was an excellent presentation.
Many thanks.
Thank you. Okay, we do have another question from Antonio. Assuming we have the use case, what kind of skills and expertise are required at a company?
So in general, the expertise required at the company is luckily exactly the expertise that most companies already have, that is working with their devices. That means, for example, if something needs to be reconfigured or a new, let's say, gateway edge device needs to be installed, this is something that companies typically have. So this, let's say, this automation and manufacturing background. What we as IESA are then providing is this IT background, and either doing it ourselves or teaching people on premise on how to instantiate these concepts and how to run these concepts. So that means, let's say, the entry barrier there, to call it like this, is not very high, because we are providing the IT expertise, and then the expertise on premise needed is just, let's say, working with these devices. And as I said, this is something that is typically there already.
Okay, that answered the question.
All right, thanks. I should mention as well that we have partnerships here. The South Carolina educational institutions are very involved in these topics as well. And so for South Carolina companies, we're almost always building a collaborative team that includes partners from our educational academic institutions. Oftentimes that's really of interest to the companies, because they like to have, utilize some of the homegrown expertise here, as well as we are able to now include students in some of these projects, which is also of interest to companies here. So I wanted to make sure to mention that as well for members of the audience today. We have funding available for students as a result of the collaboration between the academic institutions that we have in the Alliance as partners, Fraunhofer USA and the South Carolina Department of Commerce. So we hope that helps to kind of make this even more appealing to you. Okay, I'm just looking, I don't see any more questions coming in right now. We do have a few more minutes, 7 minutes left though. Anyone has any more? Feel free to flip them into the chat here.
When we're giving them 2 more minutes, I'm now thinking of an anecdote Frank told me when he was working with a customer about they had quality issues. At some days in the year, the company had some quality issues with the product, and they couldn't figure out how until they kind of looked into the data that they're collecting. Frank, do you want to explore on that?
Yeah, it was a very interesting point because, as Marcel said, they had quality issues, and they, for the sake of their life, they could not figure out why. So they realized that the quality issues were because certain, let's say, parameters were changing. So, for example, that they had to reconfigure some configurations of tools, for example. And they realized that this was changing sometimes, so which kind of parameters resulted in which kind of, let's say, quality, but they could not figure out why exactly these parameters were changing. And then by collecting all this data using digital twins and big data analytics, they realized the following. The devices were mounted on the roof, so on the, or not on the roof, on the ceiling. And since in winter snow was falling, the roof lowered itself just a millimeter. And this, of course, resulted in the ceiling lowering itself also just a millimeter. And resulting of this was then, of course, that the devices also were 1 millimeter lower than during the summer. And this, of course, completely, let's say, flipped the parameters necessary for good quality upside down. And when they reconfigured this and the snow melted, then, of course, the parameters were wrong again. And using digital twins and big data, they could figure out that in the end, the snow on the roof was the culprit for the quality issues.
Cyber attack by snow. And now that we were talking, there was another question. Are there current users willing to speak with SD firms about their experience with implementation and ongoing impressions?
That's a point that I can't answer for sure, because that depends on the users. I know that there were these kind of exchanges in the past. Additionally, we are having, let's say, at least once a year, some kind, let's call it a user forum where we meet each other and exchange experiences. However, it's happening in Berlin and it's happening in German. So I'm not sure if this is worthwhile for you, but if you're interested in this, just let's say shoot me a mail and I will see what's possible. So I think, Marcel, you can, if you distribute the material later, you can also include my mail there.
Mm-hmm.
Thanks, Frank. I think that would be interesting if some of the companies, you know, maybe you can ask them, would they be willing to talk to South Carolina companies that are thinking about going down this path, just so we know. Maybe some of them are and some of them aren't, I would expect. Okay. We still have 3 minutes. Any last questions? I'm glad to see so much interest in this topic. we can also wrap it up with, you know, just kind of a South Carolina Fraunhofer USA Alliance video that gives you an impression of us here locally. Alex, would you play that? Thanks, Alex and Adrian. Not sure that the audio, at least on my end, the audio wasn't too loud, but you get an impression.
Okay.
Well, we appreciate everyone's time today. Thank you. We will be following up with you, providing a link to the materials that were used and contact information for me and Marcel and for Frank. Thank you all for spending part of your morning with us. We look forward to following up with you and touching base on this topic or any of the other technical areas that we may be able to support you in. Marcel, do you want to say anything?
I want to say a copy of that, and of course, thank you, Frank, for time and effort and having us standing here, being the expert and answering the questions. And of course, in the future, when the world is a better place, we want to have these kind of things in person with the German expert on stage.
Very gladly. Thanks for having me.
Thank you all.
Take care. Have a good day. Bye.